Okay, what we're going to head into, this whole chapter is called Conic Sections. So the first question on 8.2 notes, it says conic sections is any figure obtained by slicing a double cone. So I have pictures there. I'm not going to try to draw them, but you can see, I'll try just for fun so you can laugh at me. Anytime you slice a double cone, we're going to get a conic section. I don't know, some mathematician before TV was really bored. So if you slice it this way, and you can see the picture in there, you're going to get a parabola, okay? If you have a cone and you just slice it straight across once, aren't I a great artist? If you cut it this way, no matter where you cut it, just straight across, you're going to get a circle. I should write it. I mean, this is in your notes too, in the printed notes. If you cut it, if let's say you don't have a steady hand and you don't cut it straight across when you're trying to cut a circle, and you cut it this way a little bit, you're going to get an ellipse. It's like an oval, an ellipse and an oval. Okay, it's a smushed circle. And then if you take this double cone, yeah, most of the time we're just cutting one through half of it, and you decide to cut through, I guess purple's good, straight through both of them, like that, you're going to get a hyperbola. So these are going to be the conic sections we're going to be talking about for the rest of this chapter, okay? I can't remember if I deleted it. It's no big, the part that says a parabola can be defined as a set of points in a plane that are the same distance from the blank blank. We're not going to worry about that, so just cross that out. It's not going to be important. I pulled out some things that we didn't need in Chapter 8 for our level of understanding, even if you're going to pre-calc, okay? So I just try to bring it down and make it as simple as possible, okay? So now let's move on to the equation of a parabola in standard form. So in standard form, and I have it on there, so I don't know if you want to write it or you want to highlight it or something like that. Standard form looks like this. Y equals x minus h squared plus k. And we did this a lot. This was like all second chapter of algebra, or second semester's algebra 1, if you remember. Quadratics, graphing, all the good stuff. So we're going to look at that again. So that's in standard form. And the couple things you need to know, remember, h, k is the vertex. Notice the h was negative in the original formula. Now it's positive. So when you take it out, make sure you know you change its sign, and we'll talk about that. Remember, the axis of symmetry is where we can cut right down the center, and if we fold it on that line, the axis of symmetry is actually a line, and if we can fold it on that line, we would have the same exact on both sides. So in this case, it would be x equals h. Whatever the x value is, that's going to be the axis of symmetry. Okay? And you have this on your paper. You should just be filling out the blanks. So hopefully you're listening and not just trying to fill out the blanks. You're trying to understand too. Okay. If A, the number in front here, oh, I didn't put the A on there. That would be helpful. Those of you from Clanalski's class, I'm going to make a lot more mistakes than she did. I just happen to make mistakes a lot. So I want you to know it's okay to make mistakes, but I make a lot of mistakes. So if you think I made a mistake on an answer key, just email me in a polite way, and if I did, I'll fix it, okay? And I'll thank you for it at the same time. If A is greater than 0, means A is a positive, then, and K is the minimum value. And so that means it opens up. In other words, if A is positive, we have a smiley face. And that means our vertex is going to be a minimum. Okay, I'm saying it a less fancy way. Okay, the other one, if A is negative. Oh, sorry, I went backwards. If A is less than 0, then your K is going to be the maximum. And it opens down. Our parabola opens down, or it's a frowny face. Okay? So it opens down, making then our vertex a maximum. And all of this is stuff we did already in Algebra 1. But I'm about to add a second piece to this. This is where we're heading to Algebra 2. y equals is a function, but we can also have a parabola that's sideways. The difference is it's not a function anymore, okay? Because it wouldn't pass the vertical line test. So we could have a parabola that faces right, or we could have a parabola that faces left. That's also part of what we're going to be doing here. I have to tell you, this is hard for me to wrap my brain around. There is a shortcut on the calculator, but I'm not going to show you because I always mess it up. But if you can figure it out, be my guest to use it. So you can see there we have forms of the equation. If we have our normal y equals ax minus h squared plus k, that's going to be, our vertex will be h and k, x and y. Our axis of symmetry is x equals h, normal. And then we already talked about if a is greater than 0, up or down. If a is greater than 0, smiley face. If a is less than 0, frowny face. I'm just looking at the table that you guys have on your notes. Okay, I'm kind of just reviewing it with you. Okay, so that's the one we've been doing all along. This is the equation. What I want to show you now is the sideways one. This is our vertex, axis of symmetry, and direction of open. Whoops, look, I messed up. Axis of symmetry, and here is the direction of opening. Okay, you have it nice and neat on your paper. I typed it out nice and neat. Okay, here's where things start to change. If you have x equals and your y is squared, we now have a left-right function, or left-right equation, not a function, that you have to be careful and really think differently about. The h is outside the parentheses, so that's connected to our x just like before, and the k is inside, so we have to change the sign. If you think about it, if we're doing a left-right one, looks like this. If I was to draw an axis of symmetry, it's going to go this way this time. It's going to be a horizontal line, right? If it's a horizontal line, that means it's going to be y equals whatever the y value is of the vertex. So everything's a little different. If a is greater than 0, it faces right. That makes sense. If a is less than 0, it faces left. That makes sense. Okay? So I'm going to talk about that, and you may want to stay tuned. I'm going to do a couple regular parabolas from the homework. So the first two are regular parabolas that you've done since Algebra 1, and then I'm going to do the sideways one. So again, if you think you've got the up-down ones, you're fine, or maybe you need a review. Okay, so let's do some of these. Number 1, y equals 2x minus 1 squared minus 5. The first thing I noticed when I look at this, the x is being squared. So I know this is an up-down. So I'm good with that. So I can say the direction, if I needed to, and I am going to ask that on the homework, is up, down. Up or down, I have to look first. Okay? Well, you should be able to tell because the 2 is positive, so that means we're facing up. Okay? The 2 is the A, so we're facing up. The vertex is just our normal, the number inside is inside with an x, so that's our x value. But remember, because it's in the parentheses in the original formula, it says opposite of. So the opposite of -1 is +1. And the -5 is outside, so that's your vertex. Our axis of symmetry, remember, it's always a line. So if you don't write it as a linear formula, I'm going to take points. It's always either going to be x equal or y equals. If it's an up-down facing one, it's going to be x equals. So it's x equals 1 because that's the x value of the vertex. Okay, and so I can say, we already know it opens up. So when I go to graph this, if you are not used to using your graphing calculator, I used my graphing calculator. I went to y equals. I typed in the formula. And if I have time, I'll make some videos. And then I looked at my table. I look at the graph, but then my really important thing is to look at my table. And you look at second graph to look at your table. And I start with my vertex. Well, I know my vertex is 1, -5. So I put there 1. Wow, I want to make this a little bigger. 1, 2, 3, 4, 5. And I put a dot there. And then I look at my table. I don't necessarily write it down. You can write it down if you want to. But I didn't. I just looked at the next values around my vertex, and that's how I figured out where to graph. I want to see 5 points. 1, 2, 3. I didn't draw this very straight. So I need to see 5 points. I do not want to see freehand parabolas. I need to see 5 points and then connect it as best you can, okay? That's what it should look like. And again, you could draw a table of values back in Algebra 1, and I will show you I have to do a table of values when I do right-left. I can't do it any other way. So remember, your vertex goes in the middle, and then you look at the numbers around the x values, and you fill in the rest, okay? So I found that from here, what to put into there, and then I put my dots on there. So it's up to you. If you need to write out the table, go ahead, you can. All right, let's do the next one. Oh, good. The next one's fun. Here we go. Number 2. Y equals negative x squared minus 2x plus 3. It says write that in standard form. So we need to get it looking like this. This is not in the right form, and this is what we're really getting is we're going to be completing the squares a lot, so I hope you like it. I need it to look like this with that A in the front. So the way we do that is to complete the square. So if you didn't learn how to complete the square, well, here you go. You get another lesson. So the first thing I know I need to do is I need a positive 1 as my lead coefficient on the square variable. Well, the squared variable has a negative in front of it. So in order to take care of that immediately, I'm just going to divide everything by negative 1 to deal with that. Okay? You can't complete the square unless you have a positive 1 as your lead coefficient. So now what do I have? Well, now I have negative y equals x squared plus 2x minus 3. Okay, now I can start working. The first thing when I'm completing the squares, I need to make room for the square on the right-hand side. So I'm going to move this 3 over here to kind of hold it in place. So now I have negative y plus 3, and I'm going to leave room because I need it. X squared plus 2x. And I'm going to add a box to both sides. Okay, the reason I add a box is to remind myself to add whatever I'm doing to both sides. Now, I like to do this 2 steps at once, and some people don't. We're going to half b, and I'm going to write that down below it. And where I write that, so that I don't lose it, I always put my x here without the square, because I move the square on the outside of the parentheses, and half of b goes there. Well, half of b is 1. So I'm going to divide this in half, and I write it there. And then I square it, and that's what goes in the box. And I know to square it because this is out here telling me to do that. We are making a perfect square here so that we can easily factor. That's why we're doing that. And then we can square root both sides. So we're purposely forcing this equation to be a perfect square. Well, if I put a 1 in that box, I got to put a 1 in this box. All right. So then I can finish up the left side. Negative y plus 4. I get this question a lot. Well, where did the 2 go? Where did the 1 go? Take this and let's FOIL or box it, whatever you do. And what I end up with is x squared plus 1x plus 1x plus 1. Add these two together. X squared plus 2x plus 1 is what we created here so that we could have this perfect square. That's the whole point. We didn't lose any numbers. No numbers went anywhere. We made a trinomial that was a perfect square so that we could factor it down to a perfect square so we could square root both sides. Okay, for those of you who know what's going on there, that's what's happening. Okay, created a trinomial by using the rules of algebra to have a perfect square factor. Now that we've done that, we're almost back to looking like this. Remember, this is our goal. Don't forget what our goal is to look like that. So now we got the parentheses in the square. Okay, so the next thing is I'm going to subtract 4 from both sides. So now I have negative y equals x plus 1 squared minus 4. That's almost perfect, except our y cannot be negative. So you need to be careful here. I'm going to now get rid of that. I'm going to divide this by negative 1, and then this is its own term. So we can divide that only by negative 1, and this is its own term. So be careful there. So now we have y equals, whoa, I don't know what just happened there. Y equals negative 1 x plus 1 squared plus 4. Okay, so now we can talk about the parts. So the first thing is we know it's going to be open down. The reason I know it's opening down, it's a y equals, the x is squared, and a is negative 1. So this is a frowny face. Okay? I know my vertex is going to be -1 because it's coming out of the parentheses, +4. Because I know this is an up-down facing, our axis of symmetry is going to be x equals, and what does x equal in the vertex? -1. And I don't think there's anything else, so let's graph it. I need to make my graph a little bigger here. Oh, you know what? Let me see if I can make it straight this time. I'll see if I can use this little thingy-mabobber that works sometimes. And I'll make it black. Didn't work that time. Okay, great. All right, now I'm going to put my vertex on there. -1, +4. 1, 2, 3, 4. And then again, I used my calculator like I showed you. And then I did it and put my 5 points on. Again, you don't have to show me the table at this level, but you need to have 5 points. Well, I did not ask for that. Let's get that off of there. It should be more, oh my goodness. It should be more of a U, upside down U. It's really not a V. It's hard to not make it look like a V. I turn this off, you stupid thing. Okay. Okay, there. That's what we're doing there. All right. Now we're on to our left rights. And now you can see where my brain doesn't quite work. If you've ever looked at my emergenetics, I have 2% yellow. So I had no idea people thought conceptually. And that is why I have to flex to really understand left-right, because you have to think conceptually here. I can't think structurally when I'm doing this. And so this really taxes my brain. But have I learned to do it? Yes. Do I still make mistakes? Absolutely. So I feel you when I'm teaching a certain way that it's not your preferred thinking method. I get that. All right, so number 3. Erase that. X equals y squared minus 14y plus 45. The first thing I notice on this, first of all, it's not in standard form. But the next thing I notice is that y is squared, which means I'm going to either have a left or right facing graph. So I know I'm going to have to work a little harder, and I'm going to need to concentrate a little better on this. And some of you are not going to have trouble with this because you're very conceptual, and you're just going to be able to turn it to your side with no trouble. Those are probably the same people when you did reflections and rotations and flips. No trouble in that chapter. That's my hardest chapter in geometry. It takes a lot of brain effort. Can I do it? Absolutely, I can do it. I know I have to concentrate more. All right, so that means it's not in standard form, so I have to complete the square. Good news, though, is our lead coefficient is 1, so I don't have to worry about that. So I'm going to subtract 45 from both sides. Just that I get it out of the way is really what I'm doing. And so x minus 45, leave space for our box, y squared minus 14y. And now I'm going to put my box on both sides to remind myself I need to add whatever goes in the box to both sides. I'm going to work on that right side to create a trinomial that factors into a perfect square. This is what I do first. I know where I'm headed. I'm heading here. My y is always going to be here. My first thing is that I'm going to half b. Half of b is -7. However, if I square -7, which I need to do because this tells me that's how we make a perfect square trinomial to factor it. So this is going to actually be 49, positive 49. Whatever goes in the box will always be positive because we always square it, okay? And then on this left side, that means we're going to have x plus 4. Okay, we're almost done because we just need x equals. So I'm going to subtract 4 from both sides. And for some of you more conceptual people, this is the harder part for you. You can still do it. It's just going to take a little bit more thinking for you. Okay, so let's see what I know just by looking at this equation. Well, first of all, there's no a in front, so there's really a 1. I know the y is squared, so this is going to be right-facing parabola, right-opening parabola, I should say. Okay, and that's going to tell me a couple things. The first thing I have to realize is I need to do my vertex, okay? My vertex, again, be careful. Look in the parentheses. Well, the y is in the parentheses, so that's the y value. But because it's in the parentheses, we got to do opposites. So that goes here, 7. And the 4 is on the outside, so that's the x value of the vertex. Because it's a right opening, it's going to look something like this, but nicer. That means if I draw my axis of symmetry, it's going to be a horizontal line. So this is going to be my axis of symmetry is going to be y equals, and then I use my y value for my vertex. It's y equals 7. Okay? Now let's see. I think I got everything I need, and here's where, let's see how well I can do. Okay? Now some of you, like I said, a couple people in my last year figured out how to use their graphing calculator to do this, and they could figure out the points. I tried to do it the other day, and I could not think of it conceptually, so I had to do this by hand, and here's what I did. I made a table of values. I put the vertex in the middle, and my vertex is -4, 7. Now here's the difference. Instead of putting in my x values, I'm going to put in my y values because this is sideways. And then I'm going to, I actually plug these back in because I can't figure out how to use the calculator. I plug these back in using my calculator, and I did 5 minus 7 squared minus 4, and that gave me 0. And then I did 6 minus 7 squared minus 4. That gave me -3. And I did that with each one on my calculator till I got them. And that's the only way I'm able to graph these correctly. Okay? Again, if you find a shortcut and you want to teach everybody in the class, that would be awesome. 1, 2, 3, 4, and then 7. 1, 2, 3, 4, 5, 6, 7. And I think I gave you bigger graphs so you don't have to worry about running out of room. Every once in a while, you're going to go off the graph. That's okay. And then I need to go, and I like to build around it. Then I'm going to go to -3, 6. 1, 2, 3, 4, 5, 6. And now I'm starting to see the shape, so it's getting a little easier for me. And then I go 0, 5, and 0, 9. And now I know what it looks like. It looks like this. And now I have my right-facing parabola with my axis of symmetry right there in the middle. If I fold it on that line, the equation of that line is y equals 7. Okay? All right, let's try one more. And again, if you feel like you've got it because you're very conceptual or completing the square is something you know how to do, you don't have to listen to the next one, but I'm going to do it with you. Number 4, sorry, this lesson's a little bit long. I have x plus y squared equals 4y minus 1. First thing I notice, for me especially, is the y is squared, so I really need to concentrate on this. I can't be screwing around with people around me or having a conversation because I absolutely will get it wrong if I do that. The second thing, it is not in any kind of form, so I need to get it in a form that works. Okay? So I need y squared with the y. I need x over there. There's a couple ways you could do this. I'm going to move the y squared because that's what I did in my notes when I first practiced this. It's kind of up to you. You could have moved the 4y over and the x over too. So now I have x equals -y squared plus 4y minus 1. Okay, first thing I notice, my lead coefficient is negative. So let's deal with that immediately and divide everything by -1. And we can take care of that later. Okay, so now I have -x equals y squared minus 4y plus 1. Okay, got to make room for my box. So now I have -x plus 1 plus a box equals y squared minus 4y plus a box. Okay, now I'm going to make this, I'm forcing this to become a perfect square trinomial so that I can factor it into a perfect square. So I know what I'm looking for. It looks like that. Put my y there because that's what always goes there. Half -4. What's half of -4 is -2. Square -2. Well, -2 times -2, and that's what goes in my box. 4. I'm just checking my work to make sure I'm not making any mistakes. And I did already. No. I did on my... Uh-oh. Did I make a mistake on this? Let's see. 4 goes in the box, but I have this as a -1 over here. And I'm not sure why I did that. Okay. My original equation was -1. I divided everything by -1. That makes that a +1. But then when I moved it over, yep, I screwed up, look. See, I like teaching sometimes in class because then somebody hopefully would have yelled out, you made a mistake. So this should be a -1 over here. Okay, good thing I checked my work. I did it ahead of time and made sure I got it right. Okay, so then over here then, we have -x plus 3. And the reason I don't re-record and make it look perfect, I want you to see that sometimes there's a mathematical struggle. And sometimes you're going to make a mistake, and it's okay. I do it all the time. So I kind of leave my mistakes in there just to see that even I've been doing these lessons for a couple years, and I still make mistakes sometimes. So now I'm going to move my 3 back over. And I have negative x equals y minus 2 squared minus 3. And so my problem is my negative x. So again, remember that this is a one big chunk. So we're going to divide each piece by negative 1. And we're finally got our problem in a form that we needed. X equals negative 1, y minus 2. The reason there's a negative 1 is because when I divide it, I just put it up at the top. Squared minus 3. Okay, so I do know that this is either left or right facing, so let's look at our A. Whoops, that's not what I meant to do. Our A value is negative 1, which means this is left facing. Okay, I knew it was left-right facing because the y is squared and the x is not. That means, now this is where I got to be careful, my vertex, my y value of my vertex is in the parentheses, so I got to do opposite. And then this should be y. Do I have a negative 3 there? Did I mess up again? Let's see. That should be negative, divide. That should be positive 3. Oh my gracious. I like to think I don't make this many mistakes, especially since I did this problem to practice it. That's okay. There's my vertex. I hope you guys noticed. I forgot when I divided by a negative 1 to make it a positive 3. You got to be careful. I keep trying to move too fast. Okay, so that means my axis of symmetry is going to be a y equals line. Okay, so let me see if I can do my graph. And again, this one I made a table of values, and I'll show you one more time how I did my table of values. I came and I did my x, y, just like normal. I filled my vertex in the middle, just like I always do. Hopefully I got it right. And I did because I've done this a couple times. But instead of doing my x values, I make sure my y values just count up and down. And then I plug it into my calculator to get this information. Okay? There is a way to do it looking backwards on your table of values on your graphing calculator. I just can't figure it out. It just is beyond me. So I'm doing it this way. Okay? So 3, 2. 1, 2, 3, 1, 2. And then I have a 2, 3 and a 2, 1. And then I have a negative 1, 4 and a negative 1, 0. And now I know what my parabola looks like, and it looks like that, left facing. Sorry, this one was a little long, but 3 and 4 require me to really think through them. And as you can see, even while thinking through them, I still made mistakes. So we're going to work together on our mistakes and figure out how to do the math.